Welcome to Class 27 of our medium-level refrigeration and air conditioning course. In this opportunity we are going to study in detail the table of pressure and temperature of the refrigerant gas R407a. Before continuing, you need to know all the technical characteristics of R407a gas. A link to a video is appearing on the screen with all the details you should know before doing any work with this refrigerant. Let's start by saying that the refrigerant gas in a refrigeration cycle can absorb heat from the air in a room because it has a very low temperature. In the evaporator, the heat from the air passes to the refrigerant, therefore the air loses temperature. Meanwhile, the heat that was from the air remains in the refrigerant, but there is no increase in its temperature because the refrigerant uses the heat to pass from the phase liquid to gas. However, there are refrigerants that are made from a mixture of several gases, where there can be a small increase in temperature while its phase change occurs. This phenomenon is called refrigerant creep. On the screen we have the table of pressure and temperature of the refrigerant gas R407a.
If you are interested in acquiring information about tools to carry out maintenance tasks in refrigeration and air conditioning, like a true cold professional, of good quality and at a very good price, you must watch the description part of this video. In addition, there we also have complimentary, related information that will help you in your work.
As we can see in the table, we have two pressure columns, one corresponds to vapor or dew pressure and the other to liquid or bubble pressure. This occurs because R407a has slip. Remember that slip means that the temperature of R407a changes while it is evaporating, and this aspect must be taken into account when recharging with R407a. To take this slippage into account, we are going to carry out the following analysis. Thus, for example, for an evaporator temperature of 5 degrees C, about 41 degrees F, according to the table, there are two pressure values. Absolute bubble or liquid pressure equal to 103.34 psi and vapor or spray pressure equal to 86.73 psi. At this moment the question arises, which pressure to select to work? The answer will depend on which part of the evaporator you want to achieve the selected temperature, that is, 5 degrees C or 41 degrees F. Thus, for example, if you want to achieve 5 degrees Celsius at the inlet of the evaporator, then it means that at the moment the first bubble of vapor appears while the refrigerant is in the liquid phase, its respective bubble pressure must be present. Then you would work with a low pressure in the evaporator of 103.34 psi. Since the R407a has slipped then, although at the inlet there is 5 degrees C, this value begins to increase. Therefore before the evaporator outlet, when there is liquid and vapor simultaneously, the temperature will not be 5 degrees C, but will be elderly. Like the table value, it refers to absolute values. We must subtract from this value the atmospheric pressure, the place where the equipment is located, which for this case we are going to take a value of 14.7 psi as atmospheric pressure. Subtracting 103.34 psi minus 14.7 psi gives a gauge pressure of 88.64 psi G. Now let's consider the next possibility. If we want 5 degrees C to occur not at the inlet of the evaporator, but rather at the outlet, that is, when there is pure refrigerant in the form of vapor, then we must work with vapor pressure or dew, in this case with a value of 86.73 psi. As the pressure in the table is given in absolute values, therefore you must subtract the atmospheric pressure of your location from these values. In this way, the low pressure that your manometer should mark is accurately obtained. 14.7 psi can be taken as general atmospheric pressure for quick calculations. Thus, 14.7 psi must be subtracted from 86.73 psi to obtain a manometer pressure value of 72.3 psi G. So again, another question may arise: what pressure value is most recommended to work with? Well, in reality, it is more common to work with the dew pressure, that is, to reach the temperature only up to the outlet of the evaporator. However, at this point it is important to note that for 5 degrees Celsius, as the bubble pressure is equal to 103.34 psi and the vapor or dew pressure is 86.73 psi. So, in case of working with an intermediate pressure within these two values, we would be very close to reaching 5 degrees Celsius, not at the inlet or outlet of the evaporator, but approximately in the middle of the evaporator. For example, taking the average between these values gives a pressure value of 95,035 psi absolute. Remember that we must subtract from this value the atmospheric pressure of the place where the equipment is located, which we are going to take as a general value of 14.7 psi in order to find the average pressure of the manometer. When performing the subtraction, we obtain a value of 80.335 psi G. Although it is not exact, we can say that with an evaporator pressure of 80,335 psi G, we would be very close to reaching the temperature of 5 degrees C in the middle of the evaporator. On the screen we have other pressure values that are usually used with R407a. Thus, for example, to achieve a temperature at the evaporator inlet of 0 degrees C, an absolute pressure of 88.2 psi must be kept in low. On the other hand, if you require the same 0 degrees at the evaporator outlet, then you must work with an absolute low pressure of 73.20 psi. Remember to find the low pressure you should read on your manometer. Subtract these values. The atmospheric pressure of the place where the equipment is located. For quick calculations you can take 14.7 psi. Thus, for example, to achieve a temperature at the inlet of the evaporator of minus 10 degrees C, an absolute pressure of 63.6 psi must be lowered. On the other hand, if you require the same minus 10 degrees at the evaporator outlet, then you must work with an absolute low pressure of 51 psi. Remember to find the low pressure you should read on your manometer. Subtract these values, the atmospheric pressure of the place where the equipment is located. For quick calculations you can take 14.7 psi. Thus, for example, to achieve a temperature at the inlet of the evaporator of minus 20, an absolute pressure of 43.66 psi must be lowered. On the other hand, if you require the same minus 20 degrees at the evaporator outlet, then you must work with an absolute low pressure of 34.10 psi. Remember to find the low pressure you should read on your manometer. Subtract these values, the atmospheric pressure of the site, where the equipment is located. For quick calculations you might take 14.7 psi,